Hello students, welcome back to my class. Today I'm going to start mathematical physics. The chapter is Fourier series. So what is Fourier series? So we know that periodic phenomena or problems of periodic motions are very common to engineering and science branches. So in order to solve these periodic problems, generally we take the help of mathematically, we take the help of periodic functions. Now, periodic functions are functions which repeats its value after a certain interval. So if I want to write a periodic function, so I can write a periodic function is a function which repeats its value after a certain period or certain interval. Here P is the period of the function. Now these functions further for mathematical simplification can be represented as a sum of a infinite series or sum of a infinite trigonometric series which consists of sine and cosines function which themselves are periodic in nature. So before I discuss what is Fourier series, let me go a little bit more in detail about the periodic functions and what is the use of this sine and cosine periodic functions. So say this is a sine function whose amplitude is 4. So amplitude is 4. So say this amplitude is 4. And if I write the frequency, this signal is omega is equal to 2 pi. So my frequency is 1 hertz. And now this is the periodic signal because it repeats its value. For example, here it repeats is the time scale. I can write this is the 1 second. So after each 1 second, this function repeats its value, or in terms of angle, I can say this function repeats its value after angle 2 pi. So this signal has a frequency 1 hertz. Similarly, if I write the frequency of this signal, the frequency of this signal is 2 hertz. That is, it repeats its value twice in 1 second. So this is this is my 1 second. Now, if this is a time scale t, if this is ft. So now this signal will repeat its value twice in 1 second. So this frequency is 2 hertz. Now similarly, if I find a frequency of this signal, so this omega is here 10, so my frequency become 5 hertz. And these all are sine functions. So now what happens if I take superposition of these functions? So if I add these functions, if I take superposition of this function, I get one more function which itself is periodic in nature. So this is a complex periodic function. Okay, so this is also a periodic function. This is also a periodic function. So I have taken superposition of this function 4 sine 2 pi t plus 2 sine 4 pi t and plus, here is a plus, you have a plus here, 1 sine 10 pi t. Now, so oppositely, I can say that a complex periodic function like this can be any function which is periodic, can be again broken or decomposed in its components. So here, like I have added sine function, we got this function. Okay, similarly, we can do the reverse process. We have a function and we can represent this function, it's its component. Okay, so these are the different frequencies. So basically, so Fourier series is what? Fourier series is a spectrum. So you have a function of time. You can decompose this function. You can decompose this function in terms of its frequency components. So this is a motivation behind your Fourier series. So here I have a represented function as a sum of sine, but some function require both sine and cosine, both function. Some function only can be represented by cos functions. So we'll see these things now. Now see, as I already defined, what is a periodic function? So say this example, this function repeats after a period of p. Now we'll see some sinusoidal and non-sinusoidal periodic function. So this is function is say 4 sin x. Okay, 4 sin x. That means its amplitude is 4. Amplitude is 4. And if I find the period, so in order to find the period, you just take the coefficient of this x. So the coefficient of this x is this, divide this by 2 pi. So this function sin x has the period p is equal to 2 pi. Similarly, if I take sin 2x, this has the period 2 pi upon 2. Just divide by coefficient. Here you have a sin 3x. So this has the period 2 pi divide by 3. That means if here is a x, it repeats its value after one cycle 2 pi. And if it is 2x is there, so in 2 pi angle, it repeats its value twice. So in 2 pi, you have a 2 cycles. Okay. Similarly, if you 3x inside the 2 pi, you have 3 cycles. So this is the first cycle, this is the second cycle, and this is the third cycle. And similarly, if you have say you have a function fx is equal to say some amplitude a sine nx. That means this function will have a period 2 pi by n. That is, it will repeat its value n times in 2 pi distance or 2 pi angle. Now let us see some more. So these are the example of some sinusoidal periodic functions. Now let us discuss some non-sinusoidal periodic function. So this is also a periodic function. If I define the value of this function, so this function is say, if I want to define, so f x, if I say this is fx function of x, say, then its value is 4 when my x goes between 0 to 6. So when my x is 0 to 6, and this value goes to 0 when my x is between 6 to 8. And so if I repeat this section, that means if I write f x plus 8 is equal to fx. So this together defines this waveform, because this waveforms, if I say this is a millisecond, so say this is a millisecond, so then the time period of this wave will be 8 milliseconds. If I represent it by tx is say time in milliseconds. So this will repeat again each 8 milliseconds. Similarly, say one more example, say this is my another example, non-sinusoidal periodic function. And if I want to write this function, so I can write this function. So this is say starting from 0 straight line, and say at 3 it is 3. So this is the y equal to mx type of equation. So I can define this function f equal to x in the range 0 x 3. And similarly, if I want to write this part, okay, so this part, you know the coordinates of these points, okay, and your equation is what? Your equation is mx plus c, where m is what? M is your y2 minus y1, x2 minus x1. So here you have y component 0, so this becomes 0 minus y1 is your 3, and x2 minus x1 is again 2. So this m become 2 minus 2, because this is slope is negative. So this equation will become y minus 3 by 2x plus c. And in order to see, you can use these boundaries where you know the function value. So for example, if I take x is equal to 5, x is equal to 5, then my c will become 15 by 2. So basically this equation is equal to 1 upon 2, 15 minus 3x, between x is equal to 3 and 5. So अगर यहाँ पर मैं if I put x is equal to 3, then 15 minus 6 and 15 minus 9, 6 divided by 2, so it will come 3 here. And if I put x is equal to 5, then 15, 15 is 0, so this will 0. So this is the correct equation. So this is the wave function can describe analytically. We can represent this wave by this function, and this function repeats its value after say x is equal to 5. So I can write here this function is periodic. It repeats its value after period of 5. 5 can be anything. For example, it can be seconds, or it can be some distance. So I can write fx plus 5 is equal to fx. So combined together, this function describes this wave. So now we understood what is periodic functions. So now the Fourier series says that any periodic function in the interval AB, where where p is equal to p is b minus e, where p is your b minus b, and if the function is periodic in this interval, then I can represent this function by a Fourier series. Okay, for example, if here say if period is say 2 pi, okay, so suppose say I have a period is equal to 2 pi, then what will happen? Then this function will become fx will become a naught by 2 plus n equal to 1 to infinity a n. If I p equal to 2 pi, this will become simple cos nx plus bn sin nx. Now say if period can be say 2l. If the interval is say minus L to L. Okay, here if I say period is 2 pi, that means my interval can be 0 to 2 pi, or my interval can be minus pi to pi, or in general this interval can be anything say c plus c minus c minus pi to, or say this function can be anything to c to c plus 2 pi. For example, if I put here 0, then it becomes 0 to pi. If I put minus pi, then it becomes minus pi to pi. So in general, any interval of 2 pi, I can represent this Fourier series in this manner. And similarly, if you have p equal to 2l, okay, then this function will become for 2l period a0 upon 2 plus n equal to 1 to infinite a n cos pi nx l bn sin nx pi nx upon L. Okay, if the period is L, only L, then you have a 2 pi nxl. Okay, similarly, if you have function, say time, say period is time period t, if function is t, and then f is also function of variable t. So if it's a t, you just represent, replace this x by t, and now say period is t, so this function will become, say, this function will become now a0 by 2 plus n equal to 1 to infinite a n cos 2 pi upon t n t plus b n cos 2 pi upon t n t, and this 2 pi by t again you can replace by omega, so this expression will become n omega t. Similarly, this will also become, this angle will become n omega t. So in this way you can represent any series. Now the next job is to find, if I have any function, if I want to write its periodic series, I need to calculate these constant a0, an, and bn. Okay, and these constants are called the Fourier coefficients. So in order to calculate the value of these periodic function, I use the orthogonal property of sine and cosine functions. So what is sine, cosine, orthogonality properties of sine and cosine function? So if I take, if I integrate cos and sine in integral, any periodic interval, because these are periodic function, if I integrate this in minus pi to pi or 0 to pi, cos and sine integration will give always 0, because they are orthogonal to each other. Okay, similarly, if I take sine mx, sine nx, okay, like sine x, sine 2x, sine 2x, sine 3x, that will also be 0. So, okay, so this integration will have value only when both n and m are equal, like sin x, xx, 2x, 2x, 3x, 3x. Okay, otherwise these sin x and sin nx or sin mx are also orthogonal. Similarly, is true for your cos function. If this m or n are same, then you have a value pi. Otherwise, this integration is value is 0. And this is your sin x and cos x. We know the integration of sine cos x for one cycle is 0 if you know the graph. So integration is this periodic function is nx is always 0, and you know this, if I write solve to minus pi to pi dx, this is equal to 2 pi. Now this is my say this is my periodic series. So here I am writing a0 separately. Okay, for just for convenience, you can if you want, you can bring this a0 also here. Now but see, here you have a n value is 0 to infinite for cos. Okay, for sine you have only value from n equal to bn, because bn is sine value is, so if you put n equal to 0 here, this function will become 0. So you don't have a n equal to 0 for sine sine series. Okay, for cosine series you have a 1 to infinite, and plus you have a a0 also here. Okay, so now I want to find the Fourier coefficients values. Okay, so I have the series. So I am assuming the interval, I'm solving for interval 2 pi. Okay, so interval is, I'm taking the interval minus pi to pi. Okay, and the Fourier series in this interval can be written as a0 upon 2 n equal to 1 to infinite cos nx plus bn sin nx. Okay, now I know the orthogonal properties. Suppose if I want to find an, okay, if I want to find an, then I have to make this summation 0, bn 0. So if I want to make sine nx 0, what I can do? I can just multiply this function by cos nx. Okay. If I multiply cos nx, this integration will not become 0 and this will become 0. Before that, if I want to find, say, a0, so I just integrate this function from minus pi to pi. If I integrate this function from minus pi to pi, what will become? A0 by 2 minus pi to pi dx and plus n equal to 1 to infinite a n integration, okay, uh, so integration cos of nx dx plus integration of sine nx dx, okay, from minus pi to pi. Now we are already told that integration of cos and sine is 0, so this completely becomes 0. So this gives you the value of a0 upon 2. This will give you 2 pi is equal to minus pi to pi fx dx, okay, and this gives me the value of a naught is equal to 1 upon pi minus pi to pi fx dx. This is the value of your a naught, okay. So a naught can be calculated by this value. If you don't put 2 here, then you can also write fx is equal to, you can write fx also like this, n equal to 0 to infinite a n cos nx plus n equal to 1 to infinite b n sin nx. Okay, in that case, your a0 will be defined as 1 upon 2 pi minus pi to pi fx dx. Okay, if you define a series like this, then you have a naught like this. If you define a series like this, then your a naught is same thing. They are both same thing, just different ways of representation. Now you got the a naught. Similarly, you can find a value of a and bn also. So say if I want to find, say, I value of, say, an and bn, say, if I want to find the value of an and bn, okay, say we have fx, we have a fx equal to a naught upon 2 plus an cos nx. This is n equal to 1 to infinite, and then you have a n equal to 1 to infinite bn cos of a sine of bn sine of nx. Okay. Now let us say, to say you have, now I want to find a, and so multiply, integrate this equation minus pi to pi fx cos of nx dx. Okay, if I integrate this one, okay, what will become? Let us solve this one. Now, so you have, say, a naught upon 2, and this become fx minus pi to pi uh, dx dx, and then you have this one, okay, you have, say, n equal to 1 to infinite an, and then you have say fx. Okay, so so I'm multiplying this by cos. Okay, fx I'm multiplying with only for cos. Just 1 minute. So we have already fx already is there. So I'm multiplying with cos only. So this become a0 by 2 minus pi to pi cos and next dx. Okay, and now this becomes n equal to 1 to infinite an integration minus pi to pi cos square nx, and here you become n equal to 1 to infinite bn integration minus pi to pi cos of nx and sine of nx dx. Now we know this integration value is 0, so this terms finish. Similarly, this term also finish. So you have only term remaining, only nth term is remaining. Okay, because I'm multiplying here some number. Say if I'm multiplying 5, so this will be cos 5. Okay, other terms will not be there, because all other integrations. Okay, suppose if I multiply 5, then here all causes 4 3 5, they will give you 0 overlap because they are orthogonal. Only the number which is equal to this 5, so 5 will survive. So now we know this value is pi. So now I can say my an. So this function minus pi to pi fx cos of nx dx will be equal to only an, and this is pi. Okay, this all other summation terms will be 0 because they all have a different ends. Okay, so my an will be what? My an will be 1 upon pi minus pi to pi fx cos nx dx. Okay, similarly, if I want to find now bn, okay, I can multiply this function by sine nx, then this term will become 0. Okay, this term will become 0, only this will survive. So I can same way I can prove that my bn is also equal to 1 minus pi to pi fx sine of nx dx. Okay, so that's why, and we wrote a naught y is equal to 1 upon pi minus pi to pi fx dx. Now they all have a same coefficient 1 by pi 1 by pi. That's why we wrote the series as uh, a naught. Okay, that's why we wrote the series here as a naught here. Okay, we written here a naught because we want this coefficient should be same. Okay, the coefficient should be same. So now say we finished this one. Now let us, once we know the formula, let us find the Fourier series of this function. Okay, so we have this square function, and I want to find the Fourier series of this function. Okay, so we know how to find the coefficients now. Okay, so let me say if I want to find a naught, so a naught will be simply 1 upon pi minus pi to pi. This is also defined in the interval minus pi to pi. And then after pi, again, this is the periodic. Okay, so this function is periodic by interval 2 pi, is given already, is given. And now a naught minus pi to pi fx. If I want fx dx, now this function is odd function. So for odd functions, always cos series will be disappear. So far I didn't discuss about the even and odd function. So I am solving this in the usual way. Later we will discuss the simplified uh, Fourier series for odd and even function. So here you have 1 upon pi. I can break this limit from minus pi to 0, and the value is -1. Fx value is -1. And then you have 0 to pi, and the function value is 1, that is 1 dx. And if I solve this one, this will give me 1 upon pi. Okay, this will be dx equal to x 0 minus pi. So this will be so if I solve this one, minus, so this will be pi, so this will be minus pi, and this will give you pi. Okay, so minus 0 minus plus pi, so total become minus. So this is my this will become will be 0. Okay, so similarly I can show, if I want to find, say, an. Okay, say if I want to find the an, if I want to find, say, the an, so an will be 1 upon pi. Okay, minus pi to pi fx cos of nx dx. Okay, now this can be written as a 1 upon pi minus pi to 0, values fx is minus cos of nx dx, and then you have 0 to pi, fx value is 1, so cos nx dx. Okay, and this should be 0, because I told you you can right now say this is 1 by pi minus, this will be sine nx upon n minus pi to 0, and this is your again sine nx upon n 0 to pi. Now sine 0 is 0, sine pi is also 0, here also 0, so this term will become 0. So all a n's are 0 for this function. Okay, so only we need to find the bn's. Okay, so let us find now for bn. So you have bn's. Okay, let us find now for bn. So bn again 1 upon pi to minus pi to pi fx sine nx dx. Okay, and this can be written as 1 upon pi minus pi to 0 minus 1 sine nx dx plus 0 to pi sine nx dx, and this can be simplified. I'm putting limit here 1 upon pi, and this limit goes here, so this become, so this become cos of nx, cos of minus cos of nx. Okay, let it be here, minus cos of nx upon n. Okay, 1 by pi is there, so I'm putting limit here minus pi to 0. And again, if you, and then similarly for this one, 1 upon pi. Okay, this will also become minus cos of nx upon n. The limit is 0 to pi. Okay, so let me simplify this one. So I have now bn. So if you put minus pi, cos minus theta is cos theta. So this gives me equal to 1 upon pi, and this is minus cos of n pi. Okay, and I can take out Similarly, this will also give me 1 upon n pi minus it, then I can take 0. So this give me here minus cos n pi and 0. If you put 0, okay, 0, so the 0 become plus 1 because minus is there. Okay, this minus is there. So similarly, if I write here, this minus is there, so I can put 0 first. This will minus cos of n pi or minus cos n pi plus 1. Okay. So now if I take 1 upon n pi common, yeah, if I take 1 upon, so my bn will become 1 upon n pi common. This become 2 minus 2 cos of n pi. That is 2 upon n pi 1 minus cos of n pi minus cos added 1 added, okay, minus cos n pi. So my bm becomes now my coefficient bn becomes 2 upon n pi, and then you have a 1 minus cos of n pi, which is equal to minus 1 power n. And now if I write my series fx, a's are 0, n equal to 1 to infinite, and then you have 2 upon n pi 1 minus 1 power n, and then you have a function sine of nx. This is my series, and now I can write the series fx. So series fx will be, if I put n equal to 1, then this term will become 0, okay, plus 2. If I put n equal to 1, this minus plus, this become term 2, okay, and then this become, so what I can write? I can write 2 by pi is outside, and if I put n equal to 1, this gives me 2 sin x. Okay, and if I put n equal to 2, this term will become 0. If I put 3, okay, if I put equal to 3, then what will become? If I become 3 here, then this become 3x sine 3x, and this become again 2. So 2 sine 3x plus, if I write here, say 4, this becomes 0, 5, so the odd term will come. So it will come 2, this 2 already taken out, 2 sine, and here n is also there. So this is 1 here, this is 3 here. So 2 sine 5x upon 5. So this is so on. We can write like this. And now the series will become fx will become 4 by 5, okay, sine of x plus 1 by 3 sine of 3x plus 1 by 5 sine of 5x. So you have to take only odd terms, okay, so you will only odd term will return. So you can write this series also like n is odd to infinite 2 upon n pi, okay, and this becomes 4 upon n pi, 4 upon n pi sine of nx. So you can write this series this way also. So I'll stop here. We'll discuss further more important relation in important functions, series of important function in next class. So thank you very much.